Today I'm going to work through some harder formula subject change examples. So let's get started. In this first example, x is contained within some algebra which is part of the denominator. And x is what I'm looking to get as the subject. The first job is to get x onto the top of the equation, so it's not part of the denominator. So my first operation is going to be multiplying both sides by this denominator to clear fractions. So we'll multiply both sides by ax plus q. And what this has the effect of doing, if we do a full expansion, and you wouldn't normally write all this out, you're basically multiplying ax plus q over 1, if I want to write that bracket as a fraction, and then multiplying that by p over ax plus q. And then on the right hand side we're also multiplying t by ax plus q. And then on the left hand side what happens is that these two brackets now cancel each other out. And so effectively what I have is p is equal to t lots of ax plus q. So this step here, this is effectively what's going on, but it's okay to write down this operation and then take yourself to this line here. Next thing to do is expand the bracket because x is contained within a bracket. So p equals tax plus tq. The next step is to get the x term on its own, which means I need to deal with this tq term on the right hand side. I deal with that by subtracting subtract tq from both sides. So p minus tq equals tax. Note that I'm still keeping my equal signs lined up as much as I can, and I can see what's happening line by line within the movement of the equation. Final step to get x on its own is to look at the coefficient of x. That means the information that's multiplying x, and in this case that's ta. So I'm going to undo that by dividing both sides by ta. So the left hand side becomes p minus tq all over ta, and the right hand side is just x. Job's a good one. And I underline my answer, and then I can think about going on to the next question. So in this next question, the initial confusion is caused by the fact that there are x terms on both sides of the equation. And so the first job in dealing with this is to get the x terms on one side and the non-x terms on the other side. The left hand side has vx and the right hand side has minus 7x. Recall that terms own the sign in front of them. So the simplest move here will be to add 7x to both sides. And that way that on the left hand side I'll have vx minus r plus 7x equals f. All my terms on the left hand side that have x's in them are actually all positive, which is a bonus, should we say. And then the next step is to address this minus r, which is on my left hand side, and I'm collecting my x's on the left hand side and I don't want that r there. So I'm going to add an r to both sides. So I've now got vx plus 7x equals f, what's an f, plus r. So I've filled in that r on this side and I've got to add an r on this side as well to keep the balance. And then the next step is to collect these x terms together. Now if this had been something like 2x and 7x, I could have added them together to get 9x. But this isn't a 2, it's a letter, it's a v. And so what I'll need to do with these two terms is factorize out the x. So if I take x out as a common factor, that means that I'd need to create a bracket containing a v plus 7. And I can check this because if I multiplied this back out again, x times v, vx, x times 7, 7x, that works. The right hand side hasn't changed. Final step then is to get x on its own by dividing by the coefficient, the information multiplying x. And in this case, the coefficient is the entire bracket v plus 7. So I need to divide both sides by the bracket v plus 7. And so x will equal f plus r, that whole right hand side, divided by v plus 7. Now I have x as the subject, and I can underline my answer. So far, so good. Let's move on to the next example. Stay focused, people. So the next step on this question, let's have a look at what we've got. I want to make x the subject. X is a denominator. I've got a couple of choices here. If you recall from the last video when we had a situation a bit like this, then the choice was either multiply through by x straight away to clear the denominators, or you could get the x term on its own here by adding g to both sides. And in this example, I'm going to choose to do that. I'm going to add g to both sides. T over x equals a plus g. Now, I haven't sorted out the fact that x is a denominator yet. I'm going to do that next. So, to get x on the top of the equation, I'm going to multiply through by x. Multiplying by x will clear this denominator here, so we'll just have t. And then on the right hand side, that whole right hand side will get multiplied by x. I'm not going to bother expanding the bracket here. I'm just going to write x in front of that bracket to show that x is multiplying that bracket out. Now, just like in example 2, to get x on its own, I need to remove this coefficient, this information that's multiplying x. So I'm going to divide both sides by the bracket a plus g. And so t divided by a plus g. Can put a bracket if you want, but it's not necessary as long as this information is contained completely under the division bar. Equals x. And we're done, in the words of Colin Hegarty. Underline your answer. And we're on to the next one. So in this example, x is contained within some algebra that's within a square root sign. Now, to get rid of that square root sign, I've first of all got to check that there's nothing being added or subtracted to this whole term here. And there isn't. So I'm okay to go ahead and square. If there was anything being added or subtracted to this term that was going to get in the way of the squaring process, I'd have to add or subtract appropriately so that the other information would effectively end up on the right hand side, and I'd be free to square my terms. So I'm going to square both sides of this equation. Squaring, when you have a square root of information, just simply removes the square root sign. It's the inverse operation. So this side will just become px plus m. And on the right hand side, c squared. Next, to get the x term on its own, because we're looking for x, I subtract m from both sides, because I want the x term on its own. Px equals c squared minus m. And then to get the x term on its own, again, deal with the coefficient. We're going to divide both sides by p. X equals c squared minus m all over p. Underline my answer. All looking good. And then just to show you an example where things are kind of the other way round to example 4. So in example 4, x was within a square root. This time x is actually a squared variable. It's also got something else unpleasant, and that is that this term here is negative. Remember, terms own the sign in front of them. So I would rather be dealing with a positive x term. So my first job here is I'm going to undo the fact that this is a negative term by adding that term to both sides. Net result, n equals d plus kx squared. So by adding kx squared to both sides, it's filled it in on this side, that's why it's gone, but I've also had to add it to this side to keep the balance of the equation. Next step to get the x term on its own is deal with this d. So we're going to get rid of the d. Bye-bye. Subtract d from both sides. N minus d equals kx squared. Nearly done. Before I can get the x on its own and process the x squared, I've got to deal with the k first. I've got to deal with that coefficient. So I'm going to divide both sides by k. N minus d over k equals x squared. And then we're nearly there. One last step to go. To get x on its own, I have to undo the operation that's currently happening, and x is being squared. The inverse operation of x squared is the square root of x. So we're going to take the square root of both sides. Square root of x squared is just x, and then left-hand side, n minus d over k. We're simply going to put a big square root sign over the whole thing. And if there's any ambiguity, then it doesn't hurt just to bracket the term that's being rooted like that. Nearly off the page. I think you can still see that. And if we can just fit this on. Nearly. Underline our answer to finish. All good. Hope that helps. See you next time.